Hello, everyone, and welcome to today's PV Tech Talk webinar with Maxeon Solar Technologies, where we will be learning about the company's strategies and execution in delivering unmatched returns for all customers. My name is Andy Colthorpe. I'm the Deputy Editor-in-Chief at Solar Media, publisher of PV Tech and Energy Storage News. Research just out from Bloomberg NEF found that a total of $239 billion has been invested in solar PV systems, large and small, worldwide in the first half of 2023, and that's a 43% year-on-year increase. A healthy portion of those investments is happening in the US. According to figures from the American Clean Power Association, of a total 5.2 gigawatts of utility-scale solar, wind, and energy storage deployed in the US in Q2 2023, just over half, 2.7 gigawatts, was solar PV. Outside of the utility-scale segments, residential and commercial and industrial solar, the distributed segment, is on a healthy growth trajectory too. In Q1 of this year alone, the US industry installed 1.6 gigawatts DC of residential solar PV, 391 megawatts DC of commercial, and more than 200 megawatts DC of community solar, according to another analysis group, Wood Mackenzie. It will not have escaped your attention that just over a year ago, the passing of the Inflation Reduction Act ushered in a new era of American clean energy, supporting an already thriving industry in the next phase of scale-up required if we are to have any hope of reducing the worst impacts of the climate crisis that so many of you are already being impacted with firsthand. However, today's session won't be focusing on those big picture macro topics. Instead, we will be learning about something much smaller, but nonetheless powerful and vital to the energy transition. And I'm talking, of course, about PV modules, or panels, if you like. None of those many gigawatts of solar PV can be deployed without them, and that may seem, and is, an extremely obvious point, but today, with the prices of solar modules having fallen so rapidly in the past decade, it is sometimes easy to assume they're a commoditized product, with one maker's modules perhaps almost interchangeable with another's. Well, today's speakers will hopefully help you to understand the key differentiators to look out for, both in terms of design and production quality, and in terms of applications and addressable customer base. Challenges like panel degradation, hotspots, warranty lifetimes, and assurances on sustainability and ethics are all real issues facing customers and their PV systems today, and we will be learning about these topics and much more. Speaking in today's webinar will be Maxeon's North America Director of Sales, Spencer Collette, and Tyler Vallejos, Sales and Technical Trainer at Maxeon. A short presentation from Tyler and Spencer will be followed up by a brief panel discussion, which I'll be moderating and asking a few questions. Now, as always, interaction with you, the audience, is very important to us. So please do put your questions for today's speakers into the questions tab on the right-hand side of your screen. We won't be able to answer them all, but we will do our best to take on as many as possible, and the Maxeon team will be more than happy to follow up and respond to any unanswered questions offline after we've finished. And one final point, today's session will be recorded and the recording available on demand. And so, yeah, without further ado, and with that, I'd love to hand you over to today's speakers, Spencer and Tyler.
Thanks, Andy. Appreciate you having us. So as Andy said, I'm Spencer Collette. I'm the North American Director of Sales here at Maxeon. And I'm pleased to be spending a little bit of time with you today talking about the company, our US plans, and specifically about our IBC cell and panel technology. Okay, so here's our opening statement, essentially. When we look out across the landscape of PV technologies and competitive manufacturers, we see a few things consistent across the board. So one is cell structure. Everyone essentially is making a front contact cell in their 4 module, except for of course, Maxeon. The things that they've been traditionally focused on, competitors, are driving up efficiency and driving out costs. And as several third-party studies show, key to those, the 2018 and 2020 DuPont PV reliability studies, which we'll reference later, that often comes at the cost of quality. The impact is, as Andy mentioned, it's often thought that solar modules are a commoditized product. And in large part, they may be. Around 85% of modules sold in the US are HJT or mono PERC. And that's in the US DG Res segment. And those modules are, again, front contact modules with some inherent points of weakness. So it's our goal today to educate you on Maxeon as a company, but also on our IBC technology and how we sort of think of cell and module technology, build quality, architecture, et cetera, differently. Next slide. Okay, so quick agenda. So first, we're going to take you through a little company and product overview. Sorry, can we go back? Looks like we're having a little bit of trouble with the slides here. Okay, so first, we'll take you through a company and product overview. We'll do, in the limited time that we have, a deep dive into our IBC technology. We'll talk about the warranty that technology allows us to wrap the product in. We'll spend a little bit of time talking about our sustainability and ESG. And then we'll talk a bit about how that translates into the value proposition for the installer and for the end customer. And then, as Andy said, we'll have some Q&A at the end. Okay, so quick overview, Maxeon as a company. So we've been in business for nearly 40 years. And what the infograph on the right shows is two things, essentially. One, we have been dedicated to solar 100% for the history of the company, right? We are a pure play solar company. We always have been, and we will be, certainly for the foreseeable future. It also illustrates the relationship between SunPower and Maxeon, which I'm sure a lot of people have questions about. So we like to try to get those out of the way early. So as you can see, when the company was founded in 1985 as SunPower, Maxeon and SunPower were the same company. And that was the case until about 2020. When we went through a split. So to be clear, Maxeon is a global manufacturing company. We are a product company. That's what's at our core. And we do operate the SunPower brand in all markets outside of the United States. In the US, and those who are joining us from the US will know this, SunPower is a downstream organization focused entirely on the US DG Res market. They are a fintech company. They have installation capabilities, and they sell our product to a network of dealers and homeowners directly, as well as some other products as well. So that's still a key partnership for us, but we are now two different companies with the manufacturing, R&D, and product focus going with Maxeon, and the downstream USDG focus going with SunPower. Next slide, please. Okay, so as mentioned, we're going to focus on the DG space today and on our IBC cell and panel technology. But we do like to talk a little bit about the company's global reach and also presence in other parts of the business. So we have made quite a name for ourselves in UPP over the last decade or so. I want to highlight the Gemini project there in Nevada in the top left corner. That is a 967 megawatt project that, when completed, I believe for a hot minute, is going to be the largest PV power plant in the world. Okay, a very exciting announcement. We have, as I'm sure many of you have seen, announced a U.S. manufacturing plant. And uniquely, this is a plant that is going to fabricate cells as well as modules here in the U.S. So this plant is going to be just outside Albuquerque, New Mexico. It represents $1 billion investment and a really significant sort of alignment with the administration and what's been put into the IRA for domestic content credits and adders. So very exciting to be bringing a lot of our supply chain for the Performance Series product, sell and Modco here to the US, and creating nearly 2,000 jobs in the process. Okay, quick overview of our Resi product line today here in the US. And these are some of the products that we'll be focused on today, the IBC cell being core to both. So we're selling the Maxeon Max 3 panel in a black on black and black on white configuration here in the US. Excuse me. Our volume bins for the white backsheet module are a 420 and 425 watt bin, and then for the black backsheet, it is a 410 and 415 watt bin. Quick look at our commercial product line. So here in the US, again, we are selling the Max 3 128 cell module. That's there on the left. That's a 470 to 485. Higher voltage module, great for car canopies and larger applications. We have the Max 3, which I just mentioned, available for, the fit there is really rooftop applications. Max 6, which is our larger cell module, which comes in the 450 to 475 watt bins, is kind of a catch-all for everything. It's applicable for free field, car canopies, rooftop, etc. And then for some larger applications, we have the Performance 6 bifacial module. That's similar to the product that we'll be building in Albuquerque in 2025 and 26. And then coming later next year, we have a frameless module for mobile applications and other applications that need a lighter weight, somewhat flexible panel called Max Air coming out. So exciting product line here to address really all commercial applications. Okay, and with that, I'm going to turn it over to Tyler to take us through some of our technological advantages, specifically durability.
Perfect. Thank you for that, Spencer. Again, my name is Tyler Vallejos. I'm going to be the sales and technical trainer for Maxeon within this presentation. And I wanted to quickly dive into our Max 3 residential product, as mentioned earlier by Spencer, and the advantages that we have in a nutshell. So, to no surprise, we've been an industry leader in performance, durability, and longevity. We've been shown to have superior performance in real-world conditions. So we have unrivaled shade performance and hotspot mitigation, superior performance in low light scenarios, and also have a low temperature coefficient for high performance on those hot days. On top of our technology's yield advantage, we also are an industry leader in reliability and durability. So as we're going to go later on in this presentation, our IBC technology, which is our interdigitated back contact, eliminates 91% of the most common panel failure modes, or degradation modes, I should say. And on top of that, we've been an industry leader in reliability since 2012 with a return rate of 0.005%. So that's sub 50 million parts, or 50 parts per million. And when we look at our warranty advantage, we're going to have full coverage, so module removal, replacement, shipping, and installation. And the very rare event that you might have an issue with a Maxeon panel, we fully cover that all together, as long as it's not submerged in water. And on top of that, we're going to have an energy performance guarantee of 88% efficiency at year 40. So where other manufacturers might have set efficiency at year 25, we're going to deliver that at year 40. It's slightly better, more often than not.
80% output.
Okay, percent output, correct. Now looking at standard test conditions and its role it has with solar manufacturing. Solar manufacturers go through 3 initial tests to produce their initial nameplate rating. So any type of information you see within a spec sheet undergoes these 3 simulated scenarios. So the first one is going to be cell temperature, solar radiance, and air mass, so atmospheric variables. So the issue with standard test conditions is they're not reflective of what solar panels will actually encounter on a day-to-day basis. And what I mean by that is these simulations are modeled at 77 degrees Fahrenheit with 1,000 watts per meter squared of sun axis on a typically clear summer day. So that's problematic because as we look at real-world conditions, the variables that can occur from high heat environments, rain, clouds, humidity, etc., it's not reflective of how these are going to perform, and especially how they're going to be modeled at year 10 production, year 25, and so forth. So here at Maxeon, for us to further engineer out the most efficient, most advanced, leading edge product to market, we do our own due diligence as far as our performance and also our competitors, but we also like to look at third-party validated data to further suggest how we could better refine our cell architecture. So within this graphic on the left, you're going to be looking at the DuPont Global Study of PV Reliability that was conducted in 2020. This study was primarily conducted for pure visibility to the industry as far as how these large-scale installations were failing and what those categories were. So this observation looked at 3 gigawatts worth of solar installs, which is about 9 million modules observed across 550 active installs within the globe. And within those installs, they found that hotspots and diode and J-box functions consisted of 50% of failure rates among conventional solar panels. And more alarmingly, within that 50%, 30% of those modules experienced degradation issues after their first 10 years of operation. So diving into, again, the effect that the elements can have on conventional modules and where these failure points are kind of located. So whether it's monoPERC, TOPCon, or HJT, there's some pretty consistent design features that leave these panels open to said increased degradation. So the thin silicon cells are susceptible to cracking, stemming from the installation, transportation stresses, or wind and snow loads, for example. On top of that, the thin metallic ribbons that form the cell connections are left open to corrosion from humidity or breakage from the continuous expansion and contraction that results from repeated hot and cold temperature cycles. And then when observing the impact of soiling or shading on a module, conventional technologies primarily mitigate these impacts by the panel by relying on the bypass diode. So the bypass diode helps mitigate these changes in shading due to an obstruction that is removed. However, the issue is over time, this bypass mechanism or this failure mode can actually wear the piece of the diode, effectively making it fail altogether, causing the module to operate at high temperatures that can cause said hotspots, it can cause a burn backsheet and discoloration, delamination, and the other failure modes mentioned in the previous slide. So where our Maxeon cell technology differentiates is apparent in our cell architecture. So when we look at the frames, for example, we use an aluminum design with an adhesive that is found commonly in aerospace applications. So this allows high survivability even under the most intense environmental or elemental stresses, including cyclonic wind loads. We also have an engineered encapsulant that is exceptionally resistant to moisture and electrical induced failure modes that can happen when this humidity induced moisture enters the encapsulant. So we're highly resistant there. We also have a high grade N-type monocrystalline silicon that is LID free and has the minimal impurities for the maximum power conversion. We also have our staple copper foundation that is highly conductive and malleable, keeping the solar cell electrically intact, even in the very rare event that it cracks. And we also have a reinforced tin corrosion barrier that helps prevent decades worth of corrosion possibilities that can happen with conventional modules. And then anti-reflective glass. So as mentioned, this is the high grade N-type silicon that's going to uniformly allow more production on those cloudy days. And then we also have our triple redundant cell connectors, or interconnections, I should say, that have been engineered to be highly flexible within the thermal cycling that can occur through those high temperature swings. Now looking at a Maxeon cell, IBC on the left and a conventional on the right, we're going to apply a stress test to see how these modules perform. And as you can see within this conventional cell, after a certain threshold, it's going to outright break. Versus our Maxeon IBC technology, when applied pressure, it's going to be very resilient But even to a certain threshold, again, you can even break an IBC cell. But that being said, it's going to remain fully intact. So now we're going to look at our application within a simulated shading environment. So again, Maxeon on the left, conventional on the right. And you're going to see that the conventional module almost exclusively relies on the bypass diode to help mitigate shading changes. And as mentioned, that bypass diode can fail over time, leaving the module unprotected to operating at high temperatures. Those high temperatures can degrade metal materials, cause a burned backsheet, delamination, electrical issues, and all the other failure modes or degradation modes that were found within the DuPont study. So where we have a technology advantage from a performance section is very unique as far as our ability to, again, produce more energy on day one versus monoperc, about 5% more. We're also going to produce we're going to have more energy production in high heat environments, more production in low light for power earlier in the morning, later in the evening, and on cloudy days. And we have the highest quality materials, including our grade N-type silicon cells and dual layer anti-reflective glass. So as mentioned with IBC, so interdigitated back contact, having the extra pure silicon can provide us a higher access to a broader spectrum of light than conventional modules have. As you can see on the left-hand side, the blue side of the graph, the cloud coverage on the early hours of the day can leave systems struggling to produce energy as there's no clear source from light rays. On the far right is the sunrise and sunset of the day, where conventional modules have a weakened ability to perform in these low light conditions. So where that portion of the spectrum is impacted by light escaping, Maxeon is better in not only that scenario, but also those early morning and late evening applications. So in short, we're able to produce more energy in the morning and more energy later in evening and on cloudy days. And here's an animation that can kind of, further build on our advantage within shading environments. So again, Maxeon on the left, conventional on the right. And we're going to see how a conventional module typically, typically performs within shaded environments. So again, we're going to have a leaf fall in this scenario. And as you can see, a sixth of the cell is going to stop its production due to that shading, versus the Maxeon solar panel is able to power through an obstruction with only minimal shading loss altogether.
Yeah, I just want to mention quickly that the videos are a little bit tough to see. Unfortunately, the animation is not coming out quite like it did, I think, when we tested this out. But just a note for any of our attendees, if you go to YouTube and go to the Maxeon channel, there are narrated versions of the videos that we've shown, as well as others that talk you through sort of the technological advantages in these simulated conditions.
Perfect. Thank you for that, Spencer. And with that, I'm actually going to turn it back to you to compare our IBC technology versus HJT and the other leading solar cell technology in the market today.
Yeah, thank you, Tyler. So the question is, how does this actually bear out in the real world, right? So we ran some simulations in PV-Syst as well as PV mismatch, and wanted to show sort of an apples to apples comparison of our IBC technology with some of the leading front contact technologies. So from an output perspective, in the leaf drop scenario, we're going to be outputting 91% of our rated watts compared to 83% with an HJT module. Reason being, again, that a leaf fall or some sort of debris, a shading scenario like that would turn on a bypass diode for half of that, 1/6 of this split panel here. And that would shut down in order to protect the module 1/6 of the cell. Showing performance at year 25, we've both got 92% output. Now we're modeling, a spec sheet or warranted output guarantee here. And HJT or some of the leading HJT manufacturers have come up to match our warranted output and degradation rate of 0.25% per year. It is worth mentioning here. So I want to give them credit where credit's due, right? It is, however, worth mentioning that HIT and now HJT has been produced by several different companies over the life of that technology. And the companies that are currently producing it and importing it into the US market today have not been producing it for longer than 4 to 5 years. Some are younger than that. Whereas, we've been in commercial production for closer to 25 and have been, 100% dedicated to solar for 40. So it remains to be seen whether those products will actually do this for the warranted life. But acknowledge that, they have put a really robust warranty behind that product from a production standpoint, and, credit where credit's due. In the same vein, HJT, the leading HJT products in the US market, do perform a little bit better than ours on hot days. So they have a slightly better temperature coefficient. You can see that borne out in the numbers there. Okay, and same comparison for mono PERC. So again, we fare a little bit better here. And again, apples to apples comparison. 410 watts for Maxeon, 410 watt mono PERC panel. We wanted to use the leading technology from both, common mono PERC suppliers as well as IBC to give you sort of, again, an apples to apples comparison here. But it should be noted that, for our black backsheet product, the Max 3 112 that we sell here in the US, we do make a 415. And in white backsheet guys, we make it in 420 and 425 as well. So quick comparison here. You can see that we fare quite a bit better in shade, 91% versus 83. From an output standpoint, at year 25, they're down at 86%. We're at 92. And then from a performance on hot days perspective, we're at 91%. They're at 88.
Great. Thank you for that, Spencer. And now in this next section, we're going to be discussing how to further push out standard test conditions. So really trying to dive into how real world conditions will affect, again, not only IBC, but also the leading edge HJT and mono PERC. So we further simulated out a PV syst comparison that's going to showcase 16 modules of, again, leading edge IBC, HJT, and mono PERC. With some degradation losses embedded into said reports, and also accounting for real world location application. So in this case, we're going to be using Sacramento, California on simulating high dry summers, humidity, and cool winters. So we'll kind of pair off and see how these different systems would result on a standard roof. Standard install.
If you could go back quickly, I want to make a quick note here. So as noted on the slide, under the module type section there, you see again that everybody's got a 410 watt module. So what we're really focused on here is kilowatt hours per rated watt. And then for the inverter, it's simulated with leading microinverter technology. So this is important, right? A lot of the technological advantages that we've just talked about, performance in shade, temperature coefficient, low light, etc., are baked into the production numbers and our advantage that you're going to see here. But voltage is also at play here. So it's important to understand that other manufacturers who are attempting to achieve the same efficiency that we're able to achieve with our IBC technology must string their cells such that the module has a high operating voltage, and that limits the compatibility from an MLPE perspective. So we're not calling out, which units are used here, but this simulation was done with the best match from an MI perspective for each panel there, and some of that, is the driver. Excuse me, that is the driver for some of the production advantage that you'll see.
Correct. So when we look at year 10 performance, and again, having our systems paired with the most optimal microinverter respective to each technology, you're going to see that our year 10 production is going to be at 114,000 kilowatt hours versus HJT, for example, is at 112,000 and mono PERC's at 108 or 109,000 rounding up. And we have a general increase between HJT and mono PERC and with HJT specifically being a little lower end of 2,000 kilowatt hours, mono-PERC being close to 6,000 kilowatt hours, and pushing it out even further towards year 25, it's going to be just exponentially more as well. So again, our Maxeon system at year 25 is going to perform at 281,000 kilowatt hours. When we look at the advantage against HJT, it's again close to 6,000 kilowatt hour advantage. Mono-PERC is going to be close to 20,000 kilowatt hour advantage. And what's even more important within these simulations is the fact that these are just warranted production values. So these are the standard test conditions that are going to be apparent to the best simulation that we can do. But when we're looking past year 40, there's no power guarantee at all, because we, again, are the leader in our warranty and we have energy production guarantees. So at year 40, we're going to have a production value or energy production value of 442,000 kilowatt hours, where HJT and mono-PERC, there really is no way that we can model that, since there is no power guarantee past year 25 for them. And as mentioned earlier, speaking of our warranty, we are the leading class with a 40-year guaranteed energy and product warranty. So when we look at our annual decline with a Maxeon system, you're going to have 0.25%. And if we look at our competitors, for example, they can range anywhere from, again, that 0.25% to 0.7%. And when we look at our year 25 energy efficiency, we're going to be at 92%, where conventional warranties might dip below 92%, even all the way down to 80%. And then, as mentioned, at year 40, we're going to be at 88.3% efficiency, versus the other conventional modules and technologies have no coverage whatsoever on those sections.
Just want to make it clear again, that's output. And then to talk a little bit about service, we also include, what you can think of as like a labor warranty with every module, right? And that's for 40 years. So this includes the cost of removing the bad panel, shipping a new panel, and reinstallation. And that's something that's available to every customer, not through a closed network of installers. I like to think about that as a real harbinger of the confidence that we have in the product, which we've been able to gain through the 48 million modules that we have out in the field. Companies, publicly traded or otherwise, don't want to write warranties that they believe they will have to service that costs money, right? So we're really putting our money where our mouth is here and saying, hey, look, well, not only are we going to warranty this product to output 88.3% of its day one nameplate in year 40, we will also wrap it in a labor warranty that covers removal, replacement, shipping, and reinstallation.
Yep. And that's further displayed within this slide as well. So kind of showing our energy production advantage, where standard panels might have a 12-year product warranty and potentially a 25-year performance, with exclusions as well as to where they're installed, versus, again, Maxeon has full coverage and has the additional 15 years of a energy guarantee built into our warranty as well. So now looking at how we differentiate from a sustainability standpoint, we take this very serious in how we operate in a way that's clean and equitable towards all sectors of our business. So we are a participant within the signatory of UN Global Compact. We're actually a leader within this organization. So we help not only combat any type of policies that are very negatively impactful to the industry, but we also advocate for solutions which we can be more effective in the way that we lead. On top of that, we also have zero tolerance on human right exploitation. So no slave labor, no child labor. This applies to both manufacturing and sourcing of our materials, as far as our vendors as well. We do our due diligence to make sure that there aren't any violations on that front. And then we also participate in the Declare label. So that's something that you opt into that allows us to fully disclose to homeowners what type of materials that we use, what type of chemicals, and we are 100% lead-free, and also are void from the 190 toxic chemicals found within standard manufacturing. And yeah, on top of that, as mentioned a few times already, we are listed as the 100 most sustainable corporations in the world and are often recognized for our ability to lead on these best practices and our influence on the industry as a whole. And on top of doing all of that, we also partner with some of the most robust products in market today. So these are our pioneer partnerships. They exclusively chose our technology to advance their innovative products forward. The first one being Aptera Motors, which is the world's first solar electric vehicle, with its goal to reduce or potentially even remove the applications of charging. So that's something that they used our IBC technology to mold into their vehicle. We also have Solar Stratus, which is a green airplane, so to speak, that is going to operate purely off of renewable energy and with the goal of reaching to the stratosphere purely based off of our solar cells. We also have a zero emission ocean racing at the bottom, and then our NASA Grover. So that's our partnership with NASA that we've had since 1997, where these rovers are able to go to the utmost extreme temperatures within Greenland's ice sheet layers. And with that, I'll pass it on to Spencer for our value proposition.
Okay, so essentially what we are offering, what Maxeon offers the installer, is differentiation and customer choice. Next slide. Here's what I mean. So as mentioned before, nearly 90% of the US DG market in res is made up of various front contact cell and module types, right? So if you break that apart a little bit, you've got 68% mono PERC, 11.5% HJT, 9.9% other. So this is probably some bifacial stuff that is, flowing into the industry sort of nefariously. And then you've got 10.6% IBC. And if you look at the historical data, this comes from WoodMac, so what I'm going to speak to now does as well. If you look at the historical data for the past, let's call it, 10 plus years, you'll see that SunPower, who was the company when we were the same company, the only one selling the IBC product into the United States, has maintained between 10 and 15% market share with that product for the most part. And it's notable that that's been done through a closed dealer network and that they have been sort of fundamentally supply constrained in IBC for the past few years. So the way that a customer, commercial or res, might think about this is, okay, it's front contact and those all sort of look the same. Everybody says theirs is, the best, but essentially much of that piece of the pie, and it's a really big piece, is commoditized. And then there's IBC. And IBC is really the only cell technology that the unindoctrinated can look at, be it through some of the videos that we have available or some of the tangible product demos, and very quickly understand that, yeah, there's a difference here, right? They may not understand exactly what the advantage of our technology is, but they'll be able to see that there are no lines on the front, no wires, or bus bars on the front of the cell. And if they watch or actually do a brake kit themselves, they'll be able to see the structural rigidity that the back contact layer actually provides the product. And that sort of lays the foundation for this really is a 40-year product. It will perform better in essentially all real world conditions. So the way that I think about this is if everyone's sort of doing the same thing, and that's been driven largely in part by fundamental supply constraints, we now, in entering the market under our own brand and offering flexibility, purchase through distribution and all of the logistics and AR benefits that provides, as well as flexibility in terms of what contractors sort of have to buy and don't have to buy versus what the SunPower network has always done. We offer sort of a lifeline in a sea of the same to differentiate. And what's that differentiation look like at the customer level? So this is the customer choice piece. I think we all know conceptually that if you offer more choices to a customer, be it commercial or residential, you're often, or you should capture more of the available market, right? There's a reason that ice cream shops don't just sell vanilla. So what do those choices look like to the customer? Well, with front contact modules and cells, the real value prop when you're looking at it versus Maxeon is reduced monthly payment and shorter payback period, right? If you look at what we provide the customer our exclusive IBC technology, which enables superior aesthetics, superior durability, the highest efficiency modules on the planet, the lowest real-world degradation. We've been in business for 38 years, which in this space is quite rare. We've produced over 48 million modules, and we're the supplier to the world's largest tech and aerospace companies. What does that mean to the customer? Peace of mind, essentially, right? A lot of the brands that commercial entities and or residential potential customers are going to look at are unfamiliar to them, right? But if you're able to build the story for them based on our performance historically and our proven track record of success and leading innovation, you can give that customer real peace of mind. You can give them what they ultimately want, which is the largest offset. And that provides a path to the best long-term investment yield. Okay, quick note on the partner program. So this is something that we launched earlier in the year. Go ahead. So the partner program is a way for us to deepen our relationships with our installer partners and offer them something more than just panels, essentially. So we have two tiers, the select partner tier and the preferred partner tier. In both, we offer marketing points for co-marketing, co-branded items. And this is a program that I should note we are currently developing and expanding. So the items that you're able to use your marketing points on will be expanding over time. Think truck wraps, think pre-baked, co-branded campaigns for lead gen. So this is an exciting program that we've launched, but we are continuing to develop. And again, it's just a way for us to deepen our partnerships with our installer partners. Okay, and that's our prepared content for the day. And we will turn it over to Andy for Q&A.
All right, that's fantastic. Thank you so much to you both, Spencer and Tyler. I can see we've already got a few questions coming in from the audience. You've got a couple more minutes to get those in. But before we run to that, I am going to exercise my editorial privilege and ask our speakers a few questions myself. So, yeah, I mean, you talked a fair bit about the range of modules or panels that you've got, that Maxeon has going into the market. But yeah, what are kind of the main, and we know that as you very, very nicely alluded to and explained, there's different modules for different applications, different scales, different customer appetites and preferences, I guess you could say. So I don't know if you want to just give us a quick sort of taster of what sort of the main product offerings are from Maxeon, and what you see as being the real advantages that are being offered into the rapidly growing US market to kick us off.
Sure. Yeah. So as mentioned earlier in the presentation, we offer a slightly different product range, although there is some overlap for res and commercial. For the resi market, we're focused on our Max 3 112 cell product, and that comes in black backsheet and white. We call that an AC ready module because its cells are strung for lower operating voltage, which again gives us greater MLPE compatibility. So that's our focus for USDG res, and those are both DC modules, the white and the black. For commercial, our sort of most available SKU, and this year we've had limited allocation for commercial, but that's expanding significantly next year. But our volume SKU has been the Max 6 72 cell SKU. So this is the same Max 6 that we pair with SunPower branded microinverter and supply SunPower with, but with an additional row of cells, and it's expressly for commercial applications. And again, that one's great for free field, rooftop, canopy, etc. And then we have some slightly more niche products, the Max 3 128 cell, higher voltage, traditionally has been used mostly for canopies, but we are seeing some free field applications and even some rooftop now. And then we have a limited allocation of our Performance 6 bifacial product, but perhaps more of that into this market, or excuse me, perhaps more of that will be allocated into this market next year and beyond.
Okay, awesome. And I guess, I think for more detail kind of run through and explanations, clearly, everyone watching can get in touch with you folks and really follow up in more detail because we're on a fairly, I guess, a limited time budget. But just noticed that you have the rendering of the upcoming factory behind you, Spencer. So I'm going to ambush you and say, what are the panels on the roof of that going to be? No, we're not going there right now. But yeah, I was just wondering because that was an interesting one. I think when that news came across our desks at PV Tech, it was certainly among the more interesting capacity expansion plans that we've been hearing about. So I just wanted to ask, and I'm sure there's a lot about it at this stage. It's probably not for discussion in the public forum. But I think, I was just wondering, the site selection is Albuquerque, New Mexico. I'm just wondering if you can tell us a little bit perhaps about the site selection and yeah, I mean, just any other sort of color, detail and elaboration you could add at this stage, on the understanding that I expect a lot more information will be coming, I guess, in due course.
Sure. Yeah, it's to your point, very, very exciting, right? I think, as mentioned, this is driven by the IRA. So it's good to see that legislation actually having an effect on localization of supply chain and U.S. manufacturing. So we're very proud to build a panel here in the U.S. and deploy it domestically and internationally, right? You can see if I move, there are two buildings there. One is for Modco and the other is for CellFab. It's our take that you will absolutely have to fabricate cells domestically to qualify for the 10% domestic content adder in the IRA. So we've been very plain about the fact that we are going to build cells here. And then again, the product that's going to be built here, at least for now, is the Performance Series product. And so that's the mono-PERC shingled product that we didn't spend a whole lot of time on today. Traditionally, it's mostly been used for UPP applications, but there are some residential applications worldwide as well. We make an AC version of the Performance Series that we sell into Europe and parts of Asia. So it's a versatile product. In terms of site selection, there isn't a whole lot I can say here other than we're very fortunate to have had really a close partnership with Governor Michelle Grisham, who really, I will say this about site selection. We looked at a lot of potential sites, and I think this particular site came in a bit late in the game, but really shone through as the most attractive for us. So again, we're very excited to be investing in the Albuquerque community, to be bringing, initially, at 3 gig ramp, about 1,800 jobs there. And have just had a great relationship with the governor and her administration to date.
In fact, it's really fascinating to hear about that, Spencer. And I think it's also really, is reassuring the right word? I'm not sure, but to know that people are delivering on the scale that I think we're going to need across this industry. I think it's really really interesting to hear about that. And yeah, just over a year since the Inflation Reduction Act passed, as I said at the beginning, and things are changing rapidly, I think. And I think, one other thing that we kind of obviously touched on a fair bit, and it's an important part of the, let's say, the commercially available solar module. But I know that, technology companies like yourselves are always kind of going for, the next level, the next step up. So, from my knowledge, I'm aware that the products that you talked about kind of in the 22 to 23% efficiency range, 22.7, I believe, to put a number on the Max 3. But I did hear a rumbling, and I guess this is often the case with cell producers. But did hear a rumbling that there's a 24.7% efficiency module that Maxeon has achieved. Am I
Yeah,
right in that? And any more you can tell us about that at the moment?
yeah, it's super exciting. This is sort of a prototype of the next generation technology that we've been working on. Over the last decade plus, really, I guess 15 years, we have achieved record cell and panel efficiency, and then someone else has come up and usurped us in the lab. And then we've come back and gained it again. And we felt like it was important to go ahead and sort of plant a flag in the ground to say, hey, look, this is not cell efficiency. First of all, that 24.7%, you're right about that, is module efficiency. And this is what one can expect from the next generation product that we are, in the late stages of development on now. So I can't say a whole lot other than that in terms of when is that product going to be brought to market, what flavor of it will be brought to the U.S. versus deployed internationally to start. But that panel efficiency is real, and we're excited, as the leading innovators in the space, to have gained the record efficiency back.
Okay, and you know what? I was minded to go on a wave of more questions on that, but I think that's kind of not fair to the audience. So I'll let them. They've asked quite a lot of really good questions now. So um, let's let's see what they've got to say. Really, I guess. So Wenda in the audience was asking, and there's a couple of other questions about the TopCon tunnel oxide passivated contact cells. So Wenda was asking if we could compare the performance of the interdigitated back contact that you have with TopCon. There wasn't an item on market share of TopCon. I'm kind of guessing what the answer is to that, but I'll let you take that on. And there was another N-type and TopCon related question, but I think probably we'll keep it at that. Yeah. So any views on that?
Yeah, good question. And the answer you probably suspect is today we were mostly focused, as is the business here in the U.S., on the U.S. DG res market, right? And as you guys know, due to tariff restrictions, there really isn't any TopCon in the U.S. DG res market. So I can't compare performance of TopCon with IBC live today, but as it becomes prevalent, if and when it becomes prevalent in the U.S. market, we will certainly address it.
Okay, yeah, I don't think we can say fairer than that, can we? Yeah. And I think, looking to kind of present and future developments, we had a couple of questions in on, I mean, it's really nice when people ask kind of questions on a unified theme. So hopefully we can, make two audience members happy with the answers here. But Fiona asked about what is your roadmap for the next module product for residential? And then Alfonso was asking if large format modules are within your roadmap, and if so, when would you expect to launch them? So, yeah, I guess any light you can shed, keep saying this, but no pun intended, on the, sorry, folks, sorry about that. But yeah, so anything you can share on the roadmap or like, yeah, perhaps not visibility into the actual steps that might be, I guess, commercially sensitive, but, perhaps the approach taken on that.
Sure. Maybe while I answer the first question, we can get a little clarification on the second for large format. Curious as to what space the person asking is asking about, particularly is this
Right, a
UPP,
segment,
P
yeah.
series, or IBC? But I can talk about sort of the product roadmap for IBC and for residential here, certainly in the US. So the Max 3 112 DC module is going to be our volume module here for the foreseeable future, right? That said, I can tease this a little bit at least. We are working on a refresh to that module, which is somewhat imminent. Call it a little over a quarter away. The idea here is for us to apply some of the advancements that we've been working on for the next generation module, those that can be applied relatively inexpensively and quickly to the existing Max 3 line, which will help us eke out another, call it 10, 15 watts from the volume bins of each one of the Max 3 112 SKUs. So we're sort of putting a bridge in place between what we sell today, which is, still the most efficient module on the market, to sort of reestablish a little bit more of our advantage until we're able to really take back a big chunk of it with the next generation modules. Next gen won't be available until, let's call it early 24. And then, we'll ramp throughout 24 and into 25. And we don't have shareable plans on what will be focused and allocated to the U.S. market versus rest of the world at this time.
Okay, sounds pretty reasonable, but it's nice to have a little bit of that color on there. So I love it when folks ask questions directly relating to something they've seen in the presentation that they want to know maybe a little bit more about. So a question here from Vamsi in the chat, and I think it refers to Tyler, where you were talking about shading impact of, the example was leaves, of course, but it's not just leaves that cast shadows clearly. But Vamsi's asking, let's say a leaf drops in between two full cells, will it not turn a bypass diode in the Maxeon module? And I admit it's a little bit out of my technical knowledge wheelhouse, so I don't know if perhaps you can kind of interpret that for us a little bit and
I can
give us a brief answer. Yeah,
I can take this to the best of my abilities. I believe that it would not. We'd have to model the specific case, right? You'd have to know what time of day, climate, roof pitch, azimuth, everything. But would a leaf between two cells affect performance and energy flow differently than one in the middle of one cell? I do not believe so. I actually believe that we would probably perform a little bit better in the scenario that they just outlined. The key here, and the reason that we say that the cells have sort of an inherent built-in bypass diode technology or features, that is the low pass-through voltage. So our cells require quite a low voltage for power to be passed through cells that are performing less optimally than the ones around them. So less islanding, less bypass diode, turning on to actually protect that portion of the panel. So again, I believe that we would do as well, if not better, in that scenario, but we'd have to go back and check that to be sure.
Okay.
Yeah. Just to build off what Spencer's saying, in short, since our reverse bias voltage is pretty low, it will typically not trigger the bypass diode whatsoever. And that's because our back contact cells have that low reverse bias voltage compared to front contact cells.
Terrific. Okay, thanks very much for that, Tyler. So I think we're running pretty short on time, and I've seen lots of great questions coming in as well. I note as well we had quite a few questions about Maxeon's activities and supplies, into the utility scale market and into various other geographic markets outside the US. So questions around availability in Brazil and Europe. I don't think we've really got the time, and I guess it's not really, today we're kind of focusing on the residential stuff, but I will say that I'm pretty sure the folks at Maxeon will be more than happy to follow up with your questions. So questioners John and Carlos, thank you very much for those. I mean, I guess unless there's anything you guys want to say on that very briefly in terms of the different segments and geographies.
No, we can certainly pass those questions on to the right people. I will say that we're actually scoping market entry into Brazil at this time, and certainly for anything in Europe. I think that was mentioned as well. We have folks, full teams that cover virtually all parts, so we can get those questions to the right people and get you quick answers.
Awesome. I feel like you've gone on the record with that, so that's a little bit of an exclusive we got for our audience there. There
you go. I said
cool.
Scoping.
We might. see if we wake up to find my colleagues have or our rivals have written that up on their media coverage. All right, everyone. I just want to obviously thank our speakers and Maxeon for for their great presentations. I think for explaining a lot of pretty complex things in a very way that was really straightforward to understand, I think, and left people wanting to know a lot more about the IBC technology and your approach to it. So I thank you guys for that, to our speakers, but if you don't mind me saying so, even bigger thanks to the three. Well, I'm not going to give away the numbers, but the hundreds of people that registered to come on today, and obviously everyone that's going to watch it on demand later on as well. We hope you found it as interesting and illuminating as I did. And I just want to thank you all for your hard work and diligence, particularly for all of you being involved in this. It's a fantastic industry. It's so cool in terms of technology. I mean, I was looking at I think me personally, I'm probably not quite brave enough to go to the stratosphere in a solar plane, but I think probably I'm not really brave enough to actually get on a rooftop. So that's probably just me and nothing to do with the technology. I certainly wouldn't mind a solar car though. That looks pretty awesome. So from me, thank you so much. Thank you very much to Spencer and Tyler. Great working with you. I don't know if you want to just say goodbye to the folks watching out there.
Thanks all, and appreciate you having us, Andy.
Oh, no problem at all. It was a real pleasure. Thank you very much, everyone, and goodbye for now.
Thank you all. Great day.